All right, well, welcome to the first community call of 2023, community call number 75. I'm your host today, Mark Fussell. I'm a maintainer on the docs and a few other repos inside Dapr. And it's wonderful to have you join us today. Over the next couple of community calls, we're going to be diving into a set of topics here today that I'll show you the agenda, but the 110 release will be coming out in the next 6 weeks or sometime in February. So in the next following community calls, we'll also dive into a lot of the sort of 110 features and what's happening inside of that. But for today, at least, we have a great lineup where we have Isaac Johnson, who's going to talk to you a lot about modernization of apps. And he's done this in the frame of, well, what do you do to modernize the classic of all modernizations, which is mainframe code. So he's really gone for it in this one. And he'll give you a great demos of what his thoughts are around all of that. Then we'll dive into Yaron, talking about a new features coming in 110 release, about using high cardinality metrics. And then we really want to get your input as we finish up towards the last topic, which is Alessandro talking about how to use Dapr behind firewalls. You've got lockdown scenarios, but those apps want to be able to work and use Dapr. What is the mechanism and what is the approach we want to do for that? I'm really want to kind of show a demo prototype and show what that looks like. So with that, I'm going to move over to our first topic about containerizing mainframe code using Dapr and hand it over to you, Isaac. Isaac, take it away.
I think you might need to enable screen sharing for me. Oh, there it is. I'm good. All right. Can you see my screen?
It's coming up. Yep.
Yes.
All right. So today we're going to talk about containerizing mainframe code using Dapr, OpenTelemetry, Datadog, and GCP. Actually, I'm going to do more than one service with GCP. So a little bit about me. My name is Isaac Johnson. I'm a principal SRE architect at WellSky. I got about 20 years experience in SCM, DevOps, and SRE. I live in Minnesota, but I was also in San Diego for a while, and I'm an active blogger. Some of my passions are Dapr, OpenTelemetry, Kubernetes, Azure. I love presenting, and then camping, hiking, fishing with my 3 daughters. Also, I asked Midjourney to give me a Dapr hat, and it actually looks really creepy. So fun with AI. So what are the goals in containerizing mainframe code? Part of what we're trying to do here is eliminate the risk on outdated or difficult to maintain hardware. There gets to be a point, especially with very old hardware, you simply can't eBay another part. If the network card goes down, it's done. The other thing is these hardware, it's hard to find, right? You're not going to find an AIX machine readily or an old SGI IRIX. Well, those you might find, but they become hard to find and test with. So it allows us to easily update our code in a testable way. We are able to leverage the scalability, both horizontal and vertical of cloud resource. And what I mean there really is that if you have some very old mainframe code, it might have some very high demands on memory or resources, in which case you can vertically scale it, make a bigger class machine. Or you might have some things that have long running processes, and for high availability, you'd want to horizontally scale it out. So do a microservice behind a load balancer to scale out a service. Lastly, by containerizing our mainframe code, we're able to leverage the strangler pattern to deal with a monolith system. So I'm not sure. In many cases where I've seen mainframe code, what happens is you have some very large piece of the puzzle that any attempt to convert it to modern languages has failed because of the size and scale of it and just the lack of knowledge. So what you do is you start to take off bites of it. That's the strangler pattern. You break it into services and you start to convert pieces of it into new code. And Dapr would allow us to do that with the service endpoints. So the demo here, we're going to kind of use the calculator app. So I think the Dapr calculator demo is a really great one to get started because it shows you multiple languages and allows you to have different services engage with each other. I decided to pick one component out of the mix, which was the add app. I could have done subtract or divide or multiply, but I did add. And I'm going to switch it to COBOL. I'm a little better at Fortran than COBOL, but I figure, hey, stretch goals, let's do COBOL. And then the third thing we're going to do is we're going to deploy this into an on-prem K3S cluster that's orchestrated with Dapr. And then we'll orchestrate how we call the code with the front-end React app, though I'm not going to modify it, and I'll show you why. And then lastly, we're going to dig into Dapr's ability to capture trace data and send it on to OpenTelemetry, and then orchestrate the whole thing with CI/CD to an on-prem K3S and a GCP GKE cluster. All right, covered a bunch. Moving on. We're going to create that add app now. So the thing that I'm doing here is I picked just one of these pieces. You've probably seen the slide before from the Dapr website. I'm basically just going to take this one spot right here and change it over to the COBOL adder. The rest of it stays the same. So we have the C# subtractor, the Python multiplier, the Node.js divider, and the React front end. So again, the reason why we're trying to do this is we may not always have like a Commodore 64 or an old TRS-80 sitting around to leverage. So we're going to be using Docker for those that have already converted to Pacman. You can use Pacman containers, but we're going to be using containers to solve this problem. So here's how I got started. We're going to use like a Node.js with Express to invoke it, because obviously COBOL, Fortran, these languages didn't have like a web server. They were pre-web. So they often engage either with console or with files, and files become a really nice way to hand off from a React, a RESTful endpoint, and then send it on to, a RESTful endpoint with Express, then write it to a file, then read a file, and then send it back up. So here I create a basic Hello World app. You see that it's identification division. We give it program ID called sample01. We're not really changing anything in our environment or data. We move on to the procedure. This is where we define our COBOL procedure. We have the main procedure. We display my first COBOL to the console, and then we stop the run. I'm using Node 14, could have used any. I'm just comfortable in 14, so I do nvm list. I do switch to 14, and then I did an npm init. So this is creating a new Node.js app locally. And then that last line on the bottom right, you see I install Express and save it to my package.json. So here's the Docker file. I'm going to go into detail of this later, so I'm not going to do much. Suffice to say, I'm using CentOS. I'm installing COBOL along the way, and then I compile it during the build of the Docker file. So once I built that first hello world, you can see I was running it, and I can see that it's listing on 8081. I even hopped into the container and ran against the /run COBOL and saw that the output's right there. And here's that very simple server.js. You see that I basically listen on run COBOL. I run the program I compiled. I then capture the output and send it to standard out. So far, so good. We've now done Express, Node.js wrapping around COBOL. Bob's your uncle, we have a container. So then, as I was working out COBOL, and I was actually looking at paper books and Googling, I realized ChatGPT is our friend. You know, I don't use it very much, but this is one of those cases where it got me a good start. So I simply asked ChatGPT, write me a COBOL program that can read 2 lines, add them together, and write it to an output file. And it gave me an almost functioning block of code. So this is the COBOL code that we actually used in the end, and it's checked into the Git repo. And you'll see that I essentially have identification division. I give it a program ID. This one I called add numbers. Then I go ahead and define some file controls. So I have an input file called input.txt, an output file called output.txt. And when you see organization is line sequential, that just means each line is a record. As we move into our file section, you can see me defining the variables. And you can see I wanted to do a real. I really wanted to handle decimal values, but COBOL is very particular that they all have the same number of decimal places. So I decided to pivot, call it a day, and just do big ends. So COBOL has a maximum size of 38 characters. So I did 36 characters. That pick is where you define your size of memory you're allocating to a variable. So we have an input number, an output number. And then the other piece that I needed to add into this was the end of file. It's a variable, but it's a string of size 3, and it goes either FLS for false or TRU for true. As I go through the COBOL code, you see I read, I open up the input and output file, I read a line, I move on, and then I read another line, and I add it together to make a total. So now I have a total variable. And then what we see here is at the end, we move that total over to the output number. We write the output record, and we close both files and stop the run. So the known limitation here, where this won't match the current Go-based add, is not going to handle decimals, and it's not going to handle negatives. And what you're going to find is that COBOL is particular about how it writes numbers out. So it's all prefixed with zeros. So I had to handle that in code. As we move on to the server.js, again, I'm only going to cover some basics. We can see the add endpoint. This way I didn't really have to change the React app. I get in my operand 1 and 2, and I'm going to cover why I have this little regex here in a second. I go ahead and write to the input.txt file, the 2 strings. I then invoke the COBOL app. And then what you see here is when I get it out, and I probably should have done read file synchronous, but I just did read file. I take the output file and I trim away with the regular expression all those leading zeros so that you don't see them in the calculator app. The Docker file here, and here's where I'll go a little bit more into it. You see that I go ahead and I base it on CentOS. I might use a lighter Docker file in the future. I go ahead and I even installed Fortran because I plan to do some other languages later. I installed new COBOL 1.1, and then I copy all the COBOL files locally. And this little test here is just so that I can make sure the COBOL is working. So I'm running the COBOL app. I don't really care about its output. If I want to do better unit tests, I might even check that it ended up with 5555. But this is just to ensure that COBOL compiled successfully. I set up Node.js, I copy all my files in here, and then I do my running endpoint. And run cobol.sh, I don't really show it, just as an npm start. Lastly, I have a reason, there's a pattern when it comes to CI/CD, why I put in a link to my private registry at the end, and I'll cover that in a moment. So here's where we're gonna do the CI/CD. So when you're doing builds and deploys, you have a lot of choices, right? I typically use Azure DevOps, GitHub, or GitLab. And you can either use provided runners or self-hosted runners. My opinion is always use provided runners when you have the chance, because why not take the free compute? It's like free cake. Only use hosted runners when you absolutely have to. So here I'm going to use a provided runner. I'm going to build my Docker file, and I'm going to push it both up to Docker Hub, and I'm going to push it down to my Harbor registry. So I like to use the CNCF project of a Harbor registry running in my K3S. And then I don't have to deal with the whole Docker Hub rate limiting that you might have to do otherwise. And then I used GitHub just because my code was in GitHub. So I used GitHub Actions. Again, could have done a GitLab runner as well. So here's my GitHub code. And I put the little green lines in there just so you can visually see the blocks. So essentially, I first turn on a build light. I literally have a blue light at my desk. If you type that URL in right now, my light will blink on. So my build light turns on. I go ahead and I start, this is where I use that line in the Docker file. I start setting some variables of the image tag and the final version. So I grab that line, I build my container once, so I build it with the tag. And then for Docker Hub, I log into Docker Hub. And again, my secrets are stored in GitHub Actions secrets, and any CI/CD tool you have out there has secrets. So I log in and I push it to ID Johnson COBOL adder, and then I do it to my Harbor CR, and I do the same thing. I don't rebuild it. I just push another tag up to my Harbor CR, and then I love to use Datadog to capture all my metrics. So every one of my GitHub builds that I run captures some kind of count into my metrics, so I can keep track of it in dashboards. How much usage I'm doing for my different repositories. Now, Datadog does have a whole backend for CI, but just pushing it into metrics has saved my bacon a few times. And then I turn off the build light. This whole third right pane is just about what to do if things fail. So I, in a really derpy way, I blink my light. I basically turn it on, wait 5 seconds, turn it off, wait 5 seconds. So I blink my light and I update the fail count over in Datadog to mark there was a fail. So here you can see a build. We have that run, and this would run if this one failed. And you can see the container went ahead and landed over in Harbor, as well as, and you can see this today over in, because I made that public Docker Hub repo, so you can grab the same container image I'm running over there. So before we got to CD, what I was doing is just a manual apply. A manual apply, so I can delete the old Go adder. I can add my COBOL adder using Docker Hub and then see that it's running. And what's cool is I can go over to Datadog where I can view logs over time. And remember I told you about all those preceding zeros? That's from the console output. That's where COBOL puts all the zeros. I could see the console output right there. You can see I was running this just this morning. You also have the ability to do live tail here. Again, so I can watch live tail. And since I do clusters all over the place, I like to aggregate them over in Datadog. We can see metrics, and when related resources is brand new. This is a beta. It was I just discovered it this past week, where they show you some mappings just from what it can monitor around your cluster. So this is not APM data. This is what it's discovering from interconnected things. And I can click on any one of these to see data. So when I did my GKE cluster, I thought, wouldn't it be fun to use GitOps? So my deployment would be using config sync. So I go to my GitHub URL, and I'm going to pull from that deploy folder and sync. And so you can see it creates this, and we're really just kind of doing Argo. It creates this config management syncer and syncs it. And then it's really particular. So it didn't like me reinstalling the GCP ZipKit agent because I had to have a defined service credential I wasn't about to check in. And it didn't like some of my image pull secrets. So while it blocked me on it, you can see this would work if I kept it a little cleaner in my folder. I then decided to use GCP CloudTrace. And the way CloudTrace works is, and I don't want to deep dive in this, but GCP CloudTrace, which gives you 2.5 million traces a month for free, it works by installing a Zipkin-based forwarder in your cluster that, for all intents and purposes, looks just like the open source Zipkin, only it's any traces you send to that Zipkin get shoved back up to GCP, which is really super handy because all you got to do is write Zipkin output. And because Dapr can do Zipkin natively, I switched from doing an OTel endpoint I was doing here right over to Zipkin and said, send it on to the Zipkin service. Only this is my GCP forwarder. So all of a sudden, I am now getting all my spans inside of GCP CloudTrace. And this is all done by Dapr, right? Dapr's handling all of my trace data going up into GCP CloudTrace. At some point, and by the way, Mark, I got to remember to add this slide into your deck because I did this right before the call. I thought, well, why not just use the open source ZipKit, right? If I have traces, I can just do it. And the coolest part about doing this is it's the same endpoint. It's the same Zipkin service as the forwarder. I didn't have to change the Dapr app config at all. And now you can see me getting these trace data. In fact, share the screen here. It's going live right there. You can see the Zipkin data being captured and shown with the Zipkin service. Again, all done by Dapr. So this is one of those things where the demo gods ate my face, but I do want to show you what I tried to do before the demo gods ate my face. I did the Datadog gRPC and HTTP collector for OTLP. So that's 43.17, 43.18 respectively. And then I installed it. So I should be able to send OTLP traffic straight to the Datadog collector to send up to Datadog, much like CloudTrace. I set my configurations. I tried every host, every pod IP. I ran this for hours trying to debug it. At the end of the day, it just was refusing to accept the traces. So maybe it's my cluster. I don't want to blame Datadog on this, but one of those things where I really wanted to show the demo because it's very cool that Dapr now supports native trace data, from the app config on OTel. I love that. I just couldn't get my demo to work in this case. But we can at least see that related resources and metrics going on in something like Datadog for the trace data. When I added GKE, I did autopilot. I actually like autopilot. I think it's pretty handy. And so I created an autopilot cluster. It went ahead and created this. I did a connect to connect to it. And you can see that we do the Git nodes. And I'm a really big fan of installing Dapr using init-k. I know you can do the operator and the YAML and the Helm chart, but when I do Dapr init-k, then the Dapr framework installed to my cluster matches my client. And since I move around to a lot of different computers, it keeps life easy if I know that the Dapr CLI matches the Dapr running in my cluster. So I just like using Dapr init-k and upgrade that way. So I was going to show you a little bit of an end-to-end demo. What I'm going to do for time, because I'm running close to time, is I'll show you somewhat weird windows. Try this again. Come on, computer. There you go. That's weird. So here's the Zipkin collector that I'm doing a port forward on. Sometimes I use Concrete Dev for Argo. So Concrete gives you one Argo instance, so a great way to do Argo. Here's the GitHub runner, so you can see any of the details, and we can see the Docker build steps here where we built it and ran it in line. I go over here and see, well, actually I'm dealing with quotas because I got blocked on CPU credits, which is why I didn't finish orchestrating. But we could look at logs and traces inside of GCP. Here's where we can see the containers in Datadog and look at logs. And if it was working, if I had the APM working in Datadog, which I wanted to show off, we would have found it right over here in the service catalog. So again, that was just one of those things where couldn't quite get there, but it's done. I'm going to wrap with kind of some final thoughts. What you didn't see behind the scenes is in one of my clusters, I dropped Redis from my state store and used Azure Blob Storage just to be different. So I have the same deploy folder going to 3 clusters at the moment using different state stores in all of them. They're using the same service configurations. They're doing different observability. Some are doing on local Zipkin, some are forwarding trace data over to GCP. And then the configurations by and large handled by Redis. And all this was made possible with Dapr. So I'll kind of end with this slide. The repo's right there. It's shared. I'm guessing if you search for a current COBOL repo in GitHub, there's not a lot of them. That's the link to ChatGPT. And then I've written some blog posts in the past. They're a little older now on essentially containerizing COBOL, Pascal, Perl, and Fortran. So thank you. Any questions?
Yeah, this was fantastic, Isaac. Pretty good. Did you actually have the app running there, the calculator app with the COBOL adder? Do you?
Yeah.
Yeah.
What I can show you is if we do right here and do, let me see which Kubernetes cluster I'm on. Okay, so if I do the port forward over to the calculator app, which is today running the add, then I should be able to bring up the add app right here. And if I go localhost, what port did I use? 4000. Here's your add app, 8 divided by 9. And if I do 7 plus 3,
That's the one.
that is now using COBOL behind the scenes. But if I do plus 3.3, I'm guessing it'll either, that's not right, right? So, and if we do a kubectl, I think it's app equals add and do kubectl log, you can see that's 2, right? So it's Dapr behind the scenes, and do logs. You can see the adding of the numbers and obviously the mistake, 15 and 3.3 is not 30. But hey, I told you it's not perfect.
Yeah, it's pretty cool. So, I mean, your learnings from this, because in many ways, when we had a discussion before, the learnings around this was there are lots of dependencies people still have on mainframes. And there's a lot of hesitation to move away from that code. But you can take the business logic inside there, containerize it, and now move it into a completely new platform and, get rid of those mainframes that are costing you quite a bit of money.
Oh, absolutely. And, we talk about mainframe code because it's just one example, but in all of our businesses, you'll encounter just some old code, like maybe some old Ruby code, some old Perl code, some just old code. And you're like, I don't want it running on this host, but I don't know how to expose it otherwise. Dapr makes it really easy to take that thing, containerize it, and expose it on a RESTful endpoint and say, all right, we've taken that dependency away. We can fix it later, we can change it later, but now I've eliminated the need for that one old mothballed host running in the data center.
That's fantastic. Yeah, so let's open up for any other questions. So people, do anyone want any questions? Either post in the chat window or unmute yourself and just ask away.
This was really great.
Yeah, it was pretty cool. So for you, the killer Dapr features in this scenario are pretty much that ability to wrap existing code and provide all of that diagnostics and telemetry. Is that what
yeah. I mean, I didn't have to change this routine one bit, right? Yeah. The React calculator was using the Dapr URL, going to the app add method because I defined on the configuration of the pod, add app as its name. I simply dropped the new app in there. The other microservices just started routing the traffic to them, right? Using Dapr. They didn't need to know anything else other than talk to /add and it was going to go to town. So it was awesome. And then you're getting the trace data and it made life really easy.
Yeah, this is amazing. All right, this is fantastic. Well, thank you. Great demo. And thanks for sharing all your code and spending a considerable amount of time walking us through the entire way that you migrated, built, deployed, ran, and got that thing up and running. It's pretty cool stuff.
Thank you.
All right, so with that, I'm just going to hand straight over to you, Yaron, and you can share away from your screen.
All right, so I'm going to share my screen. And let me know if you can see it. You should see VS Code right now.
Yes, I see that.
All right, should I zoom in or is that okay?
Yeah, maybe zoom in a little bit.
Okay, so today we're going to talk about a feature that's coming in Dapr 1.10, which allows you to deal with high cardinality metrics. And let's just start with what I mean by high cardinality metrics. This is a Dapr sample here. It's a pretty simple JavaScript application that has a for loop and is going to go through 100 entries. And it's basically going to invoke a different service, just like we've seen in Isaac's demo here, which is using a different Dapr sample. And it's going to call an orders endpoint on the target application. And there's an order slash, and there's a URL parameter path fragment there. So for 100 calls, I'm going to get orders slash 1, 2, 3, etc. And so when you have things like order IDs or transaction IDs, which have very high variance in a production use case, this might lead to two undesirable things. One is growth of memory usage for your Dapr sidecar, because Dapr will basically be adding entries for each of these URLs that are getting traced to the metrics. And the other one, of course, is egress costs. While you ship those metrics out to your backend provider, or just network latency if it's an in-cluster provider like Prometheus running in your cluster. So let's see how to deal with that. First, let's run this sample app without the high cardinality feature. So I have an order processor here, and I'm just going to use the Dapr CLI to run it locally. So Dapr runs the Dapr sidecar and the application. I'm not going to show the server side of it because it's not really important for the demo. Now I'm going to run this app. So this is the calling app. This is basically going to invoke 100 calls on the target service. So I'm going to just run Dapr run again. It has an ID of checkout. And I'm starting the metrics port for 50/50 to see what we get. And let's run this guy. And we can see that we've just shot over 100 requests. And if I go to my browser and I look for this specific metrics, which is a Dapr service invocation metric for total number of send requests, let's find it here, then we can see that we have all of these entries. And this translates into memory usage at scale, which can create a lot of issues and also very high egress costs for your data that you're shipping out. So we have basically entries for each one of the path fragments from that for loop. So what we can do in Dapr 1.10 is configure this YAML file. This is a Dapr configuration. So you have this metric section here. It's enable true. That's default for Dapr. And what's new here is that we have this rule section. So you can basically pick any Dapr metric. In our case, it's the request send total for a service invocation, because that's what we care about. And then you can pick any high cardinality metric for you. So this metric has the method label, which contains the URL that's being invoked. So we have regular expressions and we can have multiples of them here. And so in this example, we are basically turning everything after slash orders into order slash your own. And this is basically the pair here. This is the desired entry, and this is the regular expression to match it. And if you have multiples here, you can basically target multiple strings. And if you have a duplicate match, the first one that matches will be applied. So now that we have this URL, let's kick off the Dapr sidecar again, this time with the configuration. So let me find the config here. Yeah, it's this one. All right, so what I'm changing now in this Dapr run command is I've added this part here, which is the configuration file. So I'm pointing it to that one. And let's run it. And it finished sending all the requests. I'm going to go back to the browser, refresh this one, and let's search for the metric we care about. And yeah, this is the one. We can see that the method now shows order/Yaron, which is the regular expression that matched the URL that was sent out. And you can basically pick any Dapr metrics, any label on the Dapr metric for the Dapr sidecar. So this works for Dapr sidecars, not the Dapr control plane. If requests come in, we might extend this to the Dapr control plane too. The one other thing to notice is that Dapr traces high cardinality metrics, but it also traces high cardinality traces for distributed tracing. And so we're going to enable that for tracing also, because that's another place where you might want to remove the high cardinality for things that Dapr traces. In any case, for tracing in particular, it's not as flexible as metrics. So the only high cardinality trace the Dapr gets is really the API, so the method for service invocation. The others are pretty static. It's the status code and the return value from the method, and that's pretty much it. Okay, so this is coming in Dapr 1.10. We don't have docs for that yet. We're tracking that in docs issue. Any questions? Feel free to put it in the chat. Otherwise, we can move on. I'm going to stop sharing. Back to you, Mark.
All right, thank you. I've got to say, at the end there, I was just kind of trying to capture the output from that, and so it kind of used put your own inside the output. Yes.
Yes.
All right, excellent. Any questions from anyone?
Yeah, I had a quick one. On that last screen you were showing a regex.
Yep.
Is the first part of that like a titling thing, or the right part was clearly the pattern, but what is the structure there, that regex block? Can you have more than one regex?
Yeah, you can have multiples there.
All right, good. Any other questions? If not, all right, we will then move on. And Alessandro, I'll move on to you next, where we'll dive into behind the firewall, and I'll let you take over and start sharing your screen.
Do you mind pulling up the presentation though? Otherwise, I have too many things here.
I will do, yes. Let me, I will put up the presentation. Here, you should be able to see this.
Yes. So yeah, the title behind the firewall. Our marketing team still has to come up with a better name. We are welcome, and the reason is that we don't have a marketing team, I guess. But we're welcome to get another name. But the idea here is to enable Dapr to communicate with apps, even when apps are in places like behind the firewall. So before we get into what's coming, if you can please go to the next slide. Let's take a look at what it is today. This should be fairly familiar to all of you that have used Dapr, but just to set the stage, you know that Dapr runs as a sidecar process. So essentially, the communication between Dapr and your app happens over a network, which is either using HTTP or gRPC. The communication is actually two-way, as you can see here. First of all, the app can invoke Dapr. This is the orange, yellow-orange arrow on the left. This happens, for example, when your app wants to invoke other services, when your app is trying to retrieve status, send PubSub messages, etc., etc. This is possible because Dapr exposes two servers. There's an HTTP server and a gRPC server. The app simply makes calls to those servers over the port they listen on. So as you can see here, Dapr has two servers. You can configure a port, and the app just invokes them. Pretty straightforward as well. On the second, it's the blue arrow on the right. And this is when sometimes Dapr needs to invoke your app. This happens primarily, not only, but primarily in three cases. When your app is being invoked, so another app, let's call app B, is trying to invoke your app, which is app A, and then in this case, Dapr needs to send a message to your app, or when there is an incoming message from PubSub or input binding. We call this communication channel here the app channel. So for the second scenario, since the beginning of Dapr, what we have been doing was requiring the app to expose a gRPC or HTTP server. In the yellow case, it's both. In the blue case, it's only one of the two. And this server has to be listening on a port, and we call that the app port. And then Dapr just makes calls to the app, and stuff happens. But can you please click, please? Okay, but what happens if the app cannot expose a web server? For example, imagine that the app is running on a different network from the Dapr sidecar, and it cannot accept incoming connections from Dapr because it's behind a firewall. Then, like, how can Dapr send messages to the app? Some use cases here include situations where your app is running, for example, on a very low power device, maybe think a Raspberry Pi Zero, and you want to run the app on that device, but maybe there's not enough power to also run the Dapr sidecar. So you want to run the Dapr sidecar on maybe a control server located in the LAN. Or you're running a serverless environment, or maybe for whatever reason, you just don't want your app to have open ports. So there are other opportunities that a situation like this will unblock and will become clearer in the future. So this is the present world situation. Let's look at, can you go to the next slide, please? Let's look at a demo of how you can actually run this without a listener. And this demo is currently on GitHub, and you can go there. Well, let me take over and share my screen.
All yours.
And this one here, share. This is the repo that is available, that URL there. We can put the slide back on at the end. And you can see here the sample app and also all the instructions to run this demo. And what I'm going to do, and also a technical explanation, we'll get to that in a moment. So what I'm going to do now is I'm literally just going to run this demo for you. And I have my terminal here. And in this specific case, what I'm going to do is I'm going to run Dapr inside a Docker container and running the app inside my local machine. So because Dapr is in a Docker container, it cannot communicate with my app that is not in Docker using localhost. It has to go through some sort of channel. So normally, we would not be able to do this. Like in the normal scenario, if Dapr is running in Docker, your app needs to run in Docker, or you need to configure Docker to use host networking. So how can we enable this? This is the sample app, and it's pretty much a very like typical Dapr sample app, in which you have 3 things. The app will every 2 seconds invoke itself. So this is just to simulate an incoming service invocation. And then the app has a cron binding that every second sends a message to the app. This is to simulate inbound messages from bindings. The app also listens on this service invocation is happening, and there's also the app health enabled. So again, to simulate incoming app checks. So normally, when you configure app to have an app channel, you create a new service using the Go SDK. This is using Dapr.new service, and we say to listen on this specific port. But this is not going to work in this case, and the reason is because we cannot. I mean, we can create a listener here, but Dapr cannot talk to our app. So just commenting this out, and instead using this other method that is being added to the SDK in the future. And this is all you need to do. Everything else happens automatically. The SDK does it for you, and your app doesn't even need to know that it's running without a listener. The only difference is that you have to pass a Dapr client, so like the gRPC client, to the service as well. So with this change, let me just run this. And you see that app Dapr has been initialized, and now the logs are pretty hard to read, especially when running in Docker. But you can see that every 2 seconds, the app is making the service invocation. It's receiving the service invocation. And the input binding isn't working because I'm running Docker. I forgot to mount the volume. But let me run this locally so you can also see the and here you can see also that this recovers when Dapr goes down. And here you also get schedule messages because this is actually found in the YAML file. Otherwise, like I said, I just forgot to mount it in the Docker volume. So this is really the entire point of the demo, which is that everything just works. The only difference here is that when we have these SDKs, you just switch the way you create the service from, rather than telling how to create a listener, You just use this other method that creates the app callback channel for you by going through the firewall. And if we can go back to the slides, I can also explain how this works in a more technical way. Okay, and that is the URL, by the way, if you want to try this demo yourself. I can also post it on the chat window. Could you go to the next slide, please? Okay, so how this worked. We explored a bunch of different options, and at the end, this seemed to be the simplest and option that also gave the best performance. So starting from the top, the first thing that the app does is that when it starts up, it creates a Dapr client, so to be able to invoke the Dapr server using gRPC, and invokes the connect app callback method in Dapr. That's a new gRPC method that is being added. When that thing happens, when Dapr receives that request, it starts an ephemeral TCP listener. So the port can be random or can be hard coded. In this case, when I was running Docker, I actually said always use this port because I had to export that. And Dapr starts listening on that port just for any TCP connection. Then it sends the port number back to the app. The app with the Dapr SDK, again, this is all done by the Dapr SDK transparently, establishes a TCP connection to that port on Dapr. This is just purely low-level TCP, no gRPC, no HTTP, literally just TCP. Dapr receives the connection, and at that point, there is a connection established. This works through firewalls because the app is making the outbound call to Dapr. Like Dapr is never creating an outbound connection to the app, and so this goes through firewall without any issues. When Dapr receives the TCP connection and it's established, stops the listener, and then this is where the magic happens. The application through the Dapr SDK switches the TCP connection. So it actually starts a gRPC listener on the established connection. This is kind of like I would say the hack that we put together. It's not really a hack, but this is how we made the magic work. On the established connection, we just start a listener, and all the data that goes through the TCP connection is interpreted as a HTTP2/gRPC message by the listener, and then Dapr can send messages to the app as if we were doing this the quote unquote regular way. So when the channel is established in this way, Dapr can invoke methods on the app gRPC service, just like normally, like the methods are exactly the same. We also had to establish a ping channel, which is used for heartbeats, because otherwise the app has no way to know if the connection with Dapr goes down. So this is the only thing. It's done completely transparently by the SDK, but this is the only thing that is added on top. And this is what is making this possible. Could you go to the last slide, please? What's the status of this? The runtime changes are in a pull request. They are being reviewed, and I'm hopeful that they will be merged. I don't know when, but they will be merged. And we also have work on the Go SDK, again, as a proof of concept complete that can be reviewed. We are finding some issues with the other SDKs because of the way that we are really using some low-level methods, like being able to start a gRPC listener on a TCP socket. This is currently, we're currently investigating all the other SDKs, and we know that at least JavaScript and .NET are blocked. For example, in the case of JavaScript, this seems to be requiring an actual change in the Node.js runtime, and we are exploring if we can get that done to unblock that as well. We have not investigated Java, Python, and C++ or Rust yet. I don't know if those are going to have the same issues. Yesterday, Philip had some ideas here that maybe we could get this implemented by shipping a separate precompiled static binary that we can bundle with the SDKs that acts as a proxy if the stack doesn't yet support this. This is also something that I would like to understand from the community. What you think about this, if you think this will be useful, how important it is for you, and whether as shipping another binary that will be managed by the SDK but would have to run separately could be an option as well.
This is pretty cool stuff. In many ways, would you say that this could become a way that would just make it easier just to talk to between Dapr and your application anyway?
Yes, there are many situations where even if you could start a listener, there could be situations where not having a listener might be easier. From a performance point of view, until you have less than 100 concurrent messages from the Dapr to your app, performance, actually 99, because one is used by the ping channel, performance should be pretty much the same. We will have to test that, but a single TCP socket can have up to 100 parallel gRPC streams.
Well, let's open it up for a few questions. This is it's something that we're looking towards getting done toward the SDKs to make it life easier for building these sort of apps. So we'd love to hear some questions from people.
Yeah, this is Yaron. I think you've phrased it in the context of firewall apps, but this can be also an improvement to the local development experience, the way I see it, not needing to deal with ports. And we have the whole story about how do we make multiple Dapr instances, multiple applications in the local dev box running easier. And I think this can go a long way in helping that too.
Yes.
And that is something that I was talking to Alessandro as well, where we can have multiple of these connections for multiple apps to connect the same sidecar, and we can finally have the shared sidecar experience, which can enable like more platform scenarios.
Definitely. So in a situation though where you have firewall rules for your outbound connections, this is not going to solve for that one, right?
Yes, outbound connections still need to be allowed by the firewall rules. However, usually allowing outbound connections is considered a safer thing. Of course, there are exceptions to this rule, but it's considered a safer thing than allowing inbound connections.
Yeah.
Can you find out what port, if you did a restrictions where you could only do it certain outbound ports, can you actually find out what the port is, or is that not so easy?
Yes, so the port, if you don't, there is a new CLI flag. Now you're sharing your screen, but in the current implementation, which again is all to be reviewed and to be discussed, has two new CLI flags. One is enable callback channel, which essentially tells Dapr not to create an app channel by waiting for the app to be up and calling the app, but actually waiting for the app to create the channel. And then there's another optional flag which says which port to use. If you don't pass that, the port is random. But if there are situations where, even in my case, when I was using Docker, I had to open the port from the Docker container, so I had to specifically use a port, and I passed that as a CLI option. Just like when you pass like Dapr HTTP port or Dapr gRPC port, the option I think right now is called callback channel port.
And have you run into any particular customer scenarios kind of that might just kind of further enhance this, other than sort of secure behind a firewall or anything else like this? Was there anything else that you might have run into?
Yes, one was the one that I mentioned about situations like IoT devices. And another one is in certain platforms where we saw that sometimes customers use a single listener for both the app, like for the public things, like for example, the app receiving messages from the outside, and the same port is also used for the Dapr service. And so you are in a situation where inadvertently you could theoretically have someone from the outside calling your app in the endpoints that are meant only for Dapr. This might or might not be a security issue, but having a situation where the Dapr SDK by default doesn't use a listener should solve this problem regardless.
Yeah, this looks like more of an edge case, but still very cool.
Yeah. Okay, this is good. Any more questions people would like to post in the chat or unmute? Particularly, are you looking for some more feedback on this in some way, Alessandro? If people want to give more feedback after this, how could they do that?
Yeah, there's an issue on Discord, which is in Discord, I'm sorry, on GitHub. If you go to the repo, I should probably post a link to that in the chat, and I will do it now. You can also find a link to the issue. Please comment there, or you can find me on Discord, or just let one of the maintainers know. Right now, the biggest thing that we are going to have to deal with is this, like, how do we solve the SDKs? Because yes, we can get a change merging Node.js upstream, I'm exploring ways to do that. I think there's a fairly good chance we will get that fixed there, but that that can take months potentially. And when we think about what if Java has the same issue or Python has the same issue, we don't know yet. Then what about this idea of embedding a small precompiled static binary in the SDK that will be managed by the SDK? So when you decide to start an app channel by using this callback thing, the SDK forks this process, which again is statically compiled, manages it, and uses this as a proxy to be able to do the handshake that otherwise would not be possible. So this is a very fresh idea from yesterday. I think there's some pros and cons, and would like feedback from the community on this as well.
Is the Go SDK available somewhere? Your version of it built that PR checked in somewhere for the Go SDK if people wanted to try it out?
Yes, it's in one of my branches, and the link is on the same GitHub link that I shared.
Okay. All right, great. Then if there's not any more questions, we just move on to an open discussion at the end, which really is just a chance if anyone has any particular questions outside of just these topics that they want to ask about, or of course always post these on Discord and we can ask them there. So if anyone would like to ask any particular questions that we have in the last remaining 5 minutes, feel free to unmute yourself or just post it in the chat window. All right, well, okay, sounds like not any this week. All right, so we'll see you. Thank you for all our presenters. That was a fantastic set of topics. Isaac around your modernization, Yaron around your metrics, and Alessandro around this connectivity across, connectivity between Dapr and applications and making it both easier and, of course, in secure situations. We love all those demos. We'll have a next call in 2 weeks' time, and we'll see you then. So
Thanks, Mark.
Thank you. Bye-bye.
Thanks, everyone.
Thanks, y'all.